Alright, so in the last video we created our solution class, and now here we are going to add it to our maze. So our maze should have a solution. So private solution, right? And we'll call it solution. Okay, so let's instantiate that real quick. Solution equals new solution. Perfection. Alright, so now when we're down here trying to solve our maze, we want to make this part of the solution now, or well, when we're solving it. So in this case, right now we're going through each of these coordinates and reassigning current to the retrieved. So that must mean that current, each time we should probably put, I guess, current, we should put current at this point into the solution, right? So we'll do that first here. So solution dot push current, and then we'll do that here too for all of these. So, however, if we've made it to this point and we haven't hit one of these, then all the spots have been the same, and we're gonna reassign this to 2, right? That means that we just need to start backing out now because we've hit a dead end, unfortunately. So, then we need to pop the element out of our solution. Right, and well, we need to peek, I guess, technically, right? Will peek give us our last one at this point? Maybe because we haven't pushed the newest one. So, but we're already in the bad spot. So let's try solution.pop. I'm not assigning it to anything, but that's just gonna kind of throw away that last one, I think. We'll see. Current equals solution.peek. So we're gonna take a look at the one that's on top now, the one we had previously, and then it will look and see if it's less than 1. So, or sorry, if it's equal to 0. So basically this will bring us back out to all the spots that we've had already assigned to 1. So yeah, let's just debug this and see what's going on. Sure, that's fine. Driver, yes. Alright, just gonna make sure. I'm gonna move this perspective around a little bit just so you can see. Oh, not what I wanted to do. I'm just gonna move the video around a little bit then. That's fine. Okay, so here we are. While not is solved, so it's not solved, we're gonna go in here. So I'm gonna hit F8. F8. I just want to take a look at our solution that we got here. Steps is null at this point. Our solution, we have 4 elements. We've got a coordinate. So far it's looking good. I'm actually curious about when we get here, so I'm gonna undo these breakpoints. So here, at this point, let's take a look and see what we got going on here. Our current call and row is 4, 2. So just let me pull up this maze, and we got 0, 1, 2, 3. Wait, no, sorry. 0, 1, 2. So and then this, and then 0, 1, 2, 3, 4. So this is the spot we're at right now, which is right. We should be getting there because that's our dead end. So what I want to do is make sure that the solution.pop right here is doing what it should, which would be getting rid of that 4, 2 from there, and then current should then be, what is this, 1, 4, or column 4, row 1. So we want current to update to that, basically. Okay. Okay. So current is 4.1 now, which like we wanted, and let's make sure our solution does not have 4.2 on it anymore. Solution, and then data, our last coordinate we have in here is 4.1. Perfect. So that's looking good so far. Alright, so now I guess we kind of need to figure out how we're done. And actually, that's curious. So how will we determine when we're done? Well, I guess when we reached another edge, right? So, check same spot. What's check same spot do again? Check safe. Okay, that doesn't do check safe. What do I call check safe? Actually, that's curious. Because we want to get out of the maze, right? I mean, that's the goal. So we might need to modify that a little bit here. I'm gonna keep pushing through this maze here. So let's just. So I'm just gonna hold this for a little while. Alright. So let's take a look at our solution thus far. For 1. Okay. So it's gonna run forever, is it? I want to take a look at, have we found a solution yet? Element count 3. Oh, okay, so at this point we're still backing out, I guess, right? So 2, 1 now, so row 2, sorry, 2, 1, so 0, 1, 2, 1. So now we're back here. It took us a while, we had to back out. So we have this, this, and this in our stack. So our next element should be call 2, row 2. I hate how it's showing these alphabetically, so that's why it keeps throwing me off. So let's just onwards. Where's our solution here? 4 element data. What? Oh, okay. 2, 2. Okay, so now it's finding the right way, thankfully. Alright, so now we need to, we need something that's going to say, to determine, okay, well, the first, this is the starting point. Check safe. Oh, okay, how about this? We know the starting point, right? So as long as it's not the same spot as the starting point, then we're at the end. That makes sense. Okay. Check safe. So we need to, instead of check safe, maybe we should have that be like check end or something. if, oh, sorry, no, that's not what we want. That's checking if it's right. Where's the, we need to find our logic where we do, like, if it's not equal to, like out of bounds. Where the heck did I have that implementation? Am I even checking that? I could have sworn I was checking that somewhere. Oh, okay. So, basically, okay. Alright. Let's do a check finished then, I guess. We can do that. Well, let's just do a check finished method real quick, because that sounds easy enough to implement, right? Alright, so private boolean check finished. So actually we're going to pass in our last coordinate. That's going to be our current location. Then basically we can say, hey, if this is the same as our starting, if it's not the same as our starting point, and we're at any of the edges, then we're good. Okay, so if c dot, or wait, no, if check same spot c and what do we call our start coordinate? There we go. Works. So basically, if it's the same spot as we started, then that's not the end. So return false. Else. So it's not there. If c dot get call equals 0, or c dot get call equals num calls minus 1, then return true. That's what I'm hoping anyways. Okay, so basically what I'm trying to say here is that if, that was my share, I promise. Let's see, if c.getCall equals 0 or c, so that's the saying that we're on the far left side of the maze, then we're out, or if we're on the far right side, that's what this is. If c.getRow equals 0, this would be the top, or c.getRow equals num rows minus 1, we're also returning true. Return false. This is just the other, I mean, it's gonna hit something here, but otherwise we're gonna return false. Well, actually, that's not true. It's gonna hit this probably more often than not. So let's just do check finished on current every time. Whoa. Oh, that's right. Terminate. I forgot we were running the VM. Let's switch over to job perspective again. I'm going to move the camera back up to the code. Make sure it's good. Alright. So we're going to go back up here. Each time before we do this, we're going to push the current, and then we're going to reassign is solved to equals check finished current, right? That sounds good. Alright. There we go. Why not? Okay. So, and then when we're out of here, system.out.println finished. Just because I want to see if we can actually get here and see what our solution is. So I'm going to get rid of these breakpoints now. Stop here at 113 and take a look at our solution. If it's right, then we can move on. If not, then I'm just going to keep going and figure out what's going on. Alright, oh, well, that's where we're at. That was our first breakpoint. So, this is solved as at this point true. We've solved the maze. Our solution, our steps. We haven't done the build steps method yet, but we have element count of 9, element data. Let's just take a look and see if our coordinates match up. Okay, I'm just gonna expand all these real quick. No, there. Okay. All right. So let's see what we got. We should see 0, 1, which we do. 1, 1. We do 2, 1. This we're saying column first, so I'll read it the other way. 1, 2. Row 1, call 2. There. And it should be what, 2, 2? Yep, that's right. So let's look in here now. And then we got 2, 3, the third row, so that's the next one down. Yep. We should go one more down and then start going to the right. 2, 4, that's right. And then 3, 4, that's also correct. So now we're here. And then we should do, it should say 4, 4, and then 5, 4. Alright, perfect. So we have our solution figured out now. So now the program is accurately calculating our way through the maze. So then what's the next step? Next we actually need to, let's just do one more thing quick. So at this point, let's make sure we have our, do we have steps here too? Private steps, solution steps. Why am I doing this? This is basically going to be, remember how we have in our solution class, we have this build steps method and get steps method. We're going to build our steps on our solution and then get our steps and put it back into that. So actually, wow, I don't need a separate, well, yeah, why not? You can use a local variable for that. That's a stack, isn't it? Is steps a stack? Yeah, steps. Stack. Steps. So I'm gonna, at this point when it's done, I'm gonna do solution.build steps, and then steps equals solution.get steps. So now I should have a stack of the steps in an order where we can pop them out and have it be correct. So it's going to be it's going to have the last item as the first place we want to be, but that's how we can pop them and then have, say, like a GUI keep hitting this steps now and say, hey, let's take a step through our maze. So that's how we're going to do it. And I'm just going to stop at 117 here now and show you again and make sure that we get our steps is backwards now. It should be Steps is a stack. Also 9. Let's make sure our last one is the first spot, which it is. Okay, so, and our first one is the last spot. Yeah, okay, because when we pop them, it's going to take this first. It's going to say 0, 1. Oh, that was the first place we were. So, anyways, so in the next video, I'm going to start making a graphical user interface for this program. So, check back in the next one.